welcome back. All right, we're continuing with these derivative problems. So here we go. It says find the x value on the graph of f of x equals x squared plus 6x plus 1, where the graph of x has a horizontal tangent. So first off, what does it mean horizontal tangent, right? Hopefully you're not thinking horizontal asymptote because that's not what this says. Horizontal tangent. So if I was to look at the graph of f, which by the way, we all know that's a parabola, right? And it's going to be concave up. I want to know when the tangent is horizontal. So what does that tell you, right? When a tangent line, in fact, when any line is horizontal, what does that tell you about its slope? Hopefully you're saying that would mean that the slope would be 0. So in order for me to do this problem, I can get the derivative, which remember is the slope producing machine, and then set it equal to 0. So in other words, find out when the derivative or the slope is equal to 0. And that's what I'm going to do. So let's go with our definition of the derivative, f prime of x, if I'm using Newton notation, prime notation, or maybe I can even do df dx, if I want to use Leibniz notation. Either one's acceptable. And now go to the definition of the derivative. So limit is h goes to 0. If you remember, f of x plus h minus f of x all over h. I could use the alternate form of the derivative here as well, and it's actually kind of neat how it works out, but we're going to go and stick with this one. All right, so let's do it. So how do I do it? So right now I have to simplify this function notation, right? So I have to do f of x plus h. So f of x plus h means put x plus h in the function f where you see an x. So I see an x there, I see an x there. So that's going to give me x plus h squared plus 6 times x plus h, and then plus 1. Okay? So then it would be minus, right? Minus f of x. So f of x minus f of x, well, that's f of x. So it'd be minus x squared plus 6x plus 1. But since f is more than one term, I need these parentheses. I have to subtract the entire thing. And then all of this is over h. And if I was to go ahead and chuck 0 in for h now, I'm going to get basically this minus itself up top, which is 0, and the bottom I get 0. I get an indeterminate form. So I have to try something. So the something here to try is basically simplify, multiply all of this stuff out. So I'm going to do that. So if I distribute here, this x plus h, I can't forget this, right? I got to write limit as h goes to 0 because I haven't done it yet. So when I distribute this, and maybe I'll color it up, I'm going to get x squared plus 2xh, right? Plus h squared. So that's what I get when I FOIL that out. Now I distribute the 6. I'm going to get 6x plus 6h, right? Then I have plus 1. So that's me simplifying this. And then over here to simplify this stuff, I just distribute the negative. Minus x squared minus 6x minus 1. And now all of this is over h. So if we're doing it right, good stuff is going to happen. So what good stuff happens? Well, hopefully we can see the x squareds are going to sum to 0, right? And double cross that out. All right, what else sums to 0? Well, it looks like I have the 6x and the minus 6x. That's going to sum to 0. What else crosses out? Well, it looks like the plus 1 and the minus 1 is going to sum to 0. So that means every term that's left up top has an h. So I'm going to factor that h out, and I'm going to get 2x plus h plus 6 all over h. Now, why did I do that? Well, now I can take these h's, and they're basically like factors. They divide to 1, so they can get crossed out. And so now when I go ahead and substitute 0 for h, it's going to work, right? So you remember, you're putting 0 in for h. So it'd be 2x plus 0 plus 6. So that's 2x plus 6. So our slope producing machine, our derivative is 2x plus 6. Remember what this is. This is a formula for the slopes of all of the tangent lines at any point x. So now I was asked, where is there a horizontal tangent? Well, let me take this derivative, right, and set it equal to 0. So subtract the 6 over, and I end up getting, right, divide by 2, I end up getting x equals negative 3. So that would tell me that at x equals negative 3, right, this should be the x value here, there should be a horizontal tangent. So if you don't believe that, well, then you can go over to your graphing calculator. I went ahead and I graphed x squared plus 6x plus 1, and then take a look right there, right? At that little turning point, which is where we expected it, right? It looks like, and I'll sketch this in as well, that that's where my tangent line would be horizontal, okay? So pretty neat stuff. So if you want to find out where a tangent is horizontal, that basically just means where the tangent slope is 0, just get the derivative and set it equal to 0. So nothing too bananas there. All right, so let's just look at some weird questions now. Not so much evaluating limits like we just did, but just questions that are testing us on our understanding of the derivative and the different symbols. So here we go. So it says the graph of f of x is shown below. It says the line y equals 3x minus 7 is shown to be tangent. So we're basically saying that this right here is the tangent line. All right, at x equals 1. So here is 1 right there. And it says find f of 1 and find f prime of 1. So now f of 1 might at first glance be annoying for you because you're like, well, how am I going to find f of 1? I don't know what f of x is. But think about it. You do know the equation of the line, right? So if I was to chuck 1 into that line, right, 3 times 1 minus 7 and get y equals negative 4, right? Remember, this point is not only on the curve, it's also on the line. So it would make sense then I can plug it into the line and get negative 4. So this point right here is going to be 1, negative 4. So then, all right, that's pretty cool. Then that's the answer to that question. F of 1 is going to be negative 4. All right, and it's just, finding the y value when the x value is 1. Now, what about this? What about this f prime of 1? Well, again, this is what I'm saying. It's testing you on, do you know what that means? This means the derivative evaluated at 1. So graphically, that means the slope of this tangent line at x equals 1. Well, they told you what this line is, right? This is the line y equals 3x minus 7. And hopefully you remember from back in the day that y equals mx plus b, where b is your y-intercept and m is your slope. So the slope of this line right here, right, m tan, it's going to be 3. So then, okay, that means that f prime of 1, slope of the tangent at x equals 1, that's going to be 3. And again, that's just testing you on your knowledge of the concepts that we have discovered or talked about. All right, great question. 6, it says values of f of x and f prime of x, so for the function and the derivative, the slope producing machine, are shown in the table below for selected values of x. It says using the given table values, write an equation of a tangent line to the graph of f of x having negative slope. So a little weird. So first off, equation of any line, guys, we use the point slope formula. Y minus y1 equals m times x minus x1. Now, it would have been nice if they said write the equation line at x equals 0 or at x equals 1 or at x equals negative 1, but they said write the one that's going to have negative slope. Well, all right, I guess I have to look in my slope producing machine column here and realize that this is the only data they gave me that has negative slope, right? So I'm going to be writing it at the point. Well, what's the point? The x value is negative 1, the y value is 1. What's going to be the slope at that point? The slope of my tangent line at that point would be f prime of negative 1. I love writing that. I'd like you to write that. All right, which, by the way, f prime of negative 1, according to this table, is negative 4. And so now to put it all together, right, these are the ingredients. That's the recipe. Let's bake the cake. So you're going to get y minus 1 equals negative 4 times x minus negative 1 or x plus 1. Put a happy cloud around it, call it a day. That is the equation of your tangent line. They just wanted the slope of the tangent. You'd just say the answer there would be negative 4. But since they want the equation, this is what you do. Do you need to solve that for y? No, you don't. Don't be a hero. All right. If it's a multiple choice, though, understand that the choices may have y solved for. So you do have to have the general skills to be able to solve for y if needed to. But here, we don't need to. I'm not gonna. All right. So pretty cool question. Let's go to 7. All right, 7 says let g be a differentiable function. That just means we can take the derivative of g, right, at any point x. It says the line y equals x plus 1 is tangent to the graph of g at x equals 1. So very similar to what we did before, they're just not giving you the graph. So if I wanted to kind of like sketch a graph of g of x, I mean, I don't know what it looks like, but it doesn't really matter, right? And then over at 1, go ahead and chuck in a tangent, right? Something like that. And I know that this tangent is the equation y equals x plus 1. It says which of the following must be true, okay? So you're like, all right, so it looks like they're comparing g prime of 1 and g of 1 in all of these, right? Basically greater than, equal to, less than, one's a negative of. So I guess the question is, well, how could I figure that out? Well, could you figure out g of 1, right? So if I wanted to do g of 1, could I do it? Well, that would be the y value right here. And you're like, well, again, you don't have g. No, I don't. But I do know that the graph, the function, and the tangent are sharing this point of tangency. So if I went ahead and plugged 1 into my line, 1 plus 1, and got 2, then it would make sense that this y value here would be 2. So I know off the bat that g of 1 is 2. So that's pretty helpful, okay? So you're like, all right, what about g prime of 1? Again, do you understand what g prime of 1 is? G prime of 1 is the slope of the tangent line on the graph of g at x equals 1. Well, you have the tangent here. In fact, they told you its equation. So the slope of the tangent line at x equals 1 is going to be mx plus b, right? 1. So now, oh, okay, 1's less than 2. G prime of 1 is less than g of 1. All right, so that's going to be, where the heck is that? Did they typo this up? That looks like that's a little bit of a typo. You see how they have greater than there? One of those got to be less than. All right, so let's just make this one less than. So it's going to be that. Okay, so pretty cool. All right, again, testing you on your concept of all the different notations and meanings. All right, let's take a look at 8. It says the graph of the function 2 absolute value of x plus 1 is shown below. And then it's asking now to find f prime of negative 4 and f prime of 7. Now, this is kind of interesting because negative 4 is somewhere over here. You're like, all right, I don't see the graph, right? And 7 is somewhere over here, right? And you don't see the graph. But here's the deal, right? Absolute value graphs are V's. So this line is just going to continue forever. Yes? So what would the slope of this line be? Well, it looks like, right, hits a perfect point there, perfect point there. It looks like this slope is going to be up 2 over 1. And it's going to do that forever. So no matter where I draw in a tangent line, right, no matter where I draw it, I can draw it anywhere. The slope of that tangent line, when I'm greater than negative 1, so anywhere over here, it's going to be up 2 over 1. So that would mean that f prime of 7 is just going to be 2. That's the slope. Now you might be thinking, well, is that really a tangent? Because it's hitting at a bunch of spots. But by the definition of, having those 2 points and bringing the 1 point closer to the other point, so basically the limit of f of x plus h minus f of x over h as h goes to 0, yes, these are considered tangent lines. So when you find the tangent line of a line, their slopes are going to be the same. Now, what about f prime of negative 4? Well, that's going to be on this branch, right? So this is similar. It's just the opposite, right? So now if I went from here to here, right, it's going to be down 2 over 1. That's what that slope would be, down 2 over 1. So no matter where I draw in a tangent line on this branch, including, because it does this forever, it goes that way forever, just like this went that way forever, right? The slope would be negative 2. And that's that. All right, so pretty neat. All right, let's go to the next one. According to an AP teacher who posted something on AP Classroom, she said that, believe it or not, as easy as this question is, it was seen on an AP exam. So let's read it. It says the function g is twice differentiable, and that might freak you out, but it shouldn't. That just means you can take the derivative 2 times. I know we haven't done that yet, but nothing crazy. It just means take the derivative, get a function, and then you can do it again if you wanted to. All right. It says g of 5 is 1. So now hopefully you understand that when they tell you a function of an input equals an output, they're giving you a point on the graph of g, right? So this should really translate to you that 5, 1 is on the graph is on the graph of G. Then it says the line, so it's in point slope form here. Y equals 1/8 x minus 5 plus 1, kind of like in point slope form. We move the y1 over, is tangent to the graph of G at x equals 5. So, all right. So, again, I don't know what G looks like. So, here is G, something like that. And at x equals 5, I happen to know this point here was 5, 1. And then they're telling me that, hey, this line right here, that's going to be the tangent. So y equals 1/8 x minus 5 plus 1. That's the tangent. Now, how do I know that this is working? Well, because if I look at this, right, if I actually subtracted the 1 over, I can see that, yeah, 5, 1 is on this line. So that's all good. But they told you it was on that line as well. But it makes sense that it would be based off of this equation. So now it says find g prime of 5. Right? So what is g prime of 5? G prime of 5, it's the slope of the tangent line on the graph of g at 5. So it's the slope of this little line I drew here. Well, what the heck is that? Well, I can see right here that the slope would be 1/8. Now, it's not an mx plus b form, but think about it. If you distributed the 1/8, you're going to get 1/8 x, and then you're going to get minus 5/8 plus 1. You can combine those on the end to get your intercept, but we don't care about that. The slope is still going to be 1/8. All right, so that's a good question. Not much work to show there. You didn't have to show all the stuff that I did here. I'm just doing that to hopefully explain it. All right, so then we end up with the doozy of a question. It's not really a doozy. It requires some thought. All right, I actually like this question a lot. So it says, let f of x equal x squared minus 5 for x values that are greater than or equal to 0. So it's like we're looking at that parabola, but only to the right of the y-axis, greater than or equal to 0. It says the line tangent to the graph of f of x at the point P comma f of P intercepts the x-axis at x equals 3. So, like what the heck's going on here? Maybe we should get somewhat of a visual. So we know what the graph of x squared minus 5 looks like, right? So if I was to sketch this, it's basically a parabola that has been shifted down 5 units. It's going to look more or less like this, all right? Where that y-intercept down there is negative 5. Right? Not necessarily drawing the scale, but we don't need to draw the scale. So now what we're doing here, it says the line tangent to the graph of f of x at the point P comma f of P intercepts the x-axis at x equals 3. So that's like a little bit weird here. And I don't necessarily have to draw this to scale, but like, let's think about this. P f of P, that's just a general point, right? So maybe it's up here. So this would be like some point PF of P if I drew in a tangent, and they're saying it's intercepting at x equals 3, so the point 3, 0. Fudge that, because that's my tangent, right? But it doesn't necessarily have to be there. I mean, if I'm really thinking about this, couldn't I potentially have a tangent over here that also at some general point PF of P kind of intercepts the x-axis at 3? Right? So that's kind of like the visual of what's going on. If you only drew one of them, that would be fine too, because at the end of the day, this is what we're going to do. Okay. Let's get the tangent. And that's kind of like a common thread. Like when in doubt, you learn how to take the derivative. Take the derivative of this function. So let's take the derivative of f of x here. So to do that, I'm going to use my nice little definition of the derivative. Limit as h goes to 0, f of x plus h minus f of x all over h. So that would be limit as h goes to 0. So f of x plus h is going to be x plus h squared minus 5. Yes. Then minus parentheses f of x, which is x squared minus 5. I didn't do the colors this time. Hopefully you don't need them anymore. So now what would I do? I'd spruce all this out, because if I go ahead and chuck 0 in for h now, I'm going to get this. So I have to go ahead and clean this up. So now if I go and do that, I'm going to get limit as h goes to 0, multiply this out. That's x squared plus 2xh plus h squared minus 5, then distribute the negative, minus x squared plus 5 all over h. If you're doing it right, then good things should happen. A whole bunch of stuff should simplify. So let's see, is that happening? It looks like the x squared's going to sum to 0. All right. It looks like the minus 5 and the plus 5 is going to sum to 0. So you're just left with terms up top that have h. So the last couple of problems, I've been factoring that h out up top and then crossing it out with the bottom, which is a fine way to do it. Some people are like, well, why can't you just think of it as division? So in other words, this h, not only does it divide this term in the numerator, right? But it also divides that, right? And it does. You're basically splitting the numerator up. That's how you divide in math. So if I did that, just show it into a different way, that's all. I'm left with 2x plus h. And now as h goes to 0, I just get 2x. So my slope producing machine is 2x. So now what would the slope be at this general point, pf of p, right? So what is m tan at x equals p, right? Pf of p going to be? Well, it would be f prime of p. So it would be 2p. So the slope of this tangent line is 2p. And whether I'm calling this point p f of p or this point p f of p, its slope is going to be represented by 2 times whatever p is. Okay? So how do I do it? How do I figure out what p is, right? So here's the deal. We just represented the slope at this point using the derivative. But I can also represent the slope of these tangent lines using my handy dandy slope formula that I learned back in Algebra 1. And you're like, well, why? Well, because in this particular problem, I happen to tell you that this tangent line passed through the x-axis at 3. So it passed through another point. So how can I represent the slope of this tangent line? Well, change in y over change in x. And my point here is p f of p and 3, 0, right? So change in y. That would be f of p minus 0 over 3. Actually, I'm sorry, over p minus 3. And that's just using the slope formula. Subtract the y's over subtract the x's. Now, what's the deal with f of p? Well, f of p would be me putting p into here. It's just going to be p squared minus 5, right? Minus 0, I don't need to write that, over p minus 3. So now we were able to represent the slope of this line in 2 different ways. One way using the derivative is 2p. The other way using just the slope formula, because they happen to give us this other point, as this. So what do you think I can do with this? Hopefully you're saying, oh, set them equal. So if I set them equal, if I take 2p and I make it equal p squared minus 5 over p minus 3, right? Maybe put this over 1, cross multiply. 2p times p is 2p squared. 2p minus 3 is minus 6p equals p squared minus 5. This is a quadratic equation. Subtract the p squared over, leave the 6p there, and then add the 5 over, right? And so now hopefully I can factor this. I think I can. I think p minus 5 and p minus 1 is going to work, right? Because that's going to multiply the 5 and add negative 6. So take a look at this awesomeness. I get p equals 5 and p equals 1, which that would make sense because how I drew the picture. Now, what if you didn't draw the picture this way initially? So like, what do I mean? Like you drew a parabola, you kind of sketched it correctly, and you're like, all right, I just think it's going to be, there's my tangent right there. So there's p f of p. Here's my 0.30 on the x-axis, and you went about and did the problem this way. Well, all of this would look exactly the same, and then you'd get to this point and realize that, oh yeah, there are 2 possible values. That could be this guy up here as well, right? So you got 2 values of p there. Both are going to work, all right? So what's the takeaway from this? There are going to be moments on the AP exam where they want you to, represent the derivative using calculus, right? So in other words, represent the slope using calculus, which is the derivative, but then also represent the slope using some non-calculus stuff that you learned back in the day, like the slope formula, right? And then setting them equal, right? So this is the slope represented using the derivative. This is the slope represented using basically change in y over change in x, all right? So solid stuff. Hope everyone's good. Calculus is starting to get fun.